Welcome, viewers. So now we are into using properties and some more unit circle notes. Before you begin this, please, if you are having trouble the last 2 days watching the videos and the notes, that material is difficult the very first time you see it. Please make sure you go to Math Lab during your study hall. Please make sure you are getting help. Speak up in class because if you're having trouble, other people are having trouble, and I do better at teaching when you can tell me what you're having trouble with. So let's move on. So the last time we really saw arc length and area of a sector was back in geometry, and we were still dealing in degrees. So now we're dealing with radians, and we've got a new formula here. For a circle of radius r, a central angle of theta radians, sub-tens, and that just means is in between these two, the initial side and the terminal side. An arc whose length s is s equals r times theta, and theta is in radians, so that's 2 pi all the way around the circle. So all you really have to remember is r times 2 pi. So for the area, we've got, and again it's in radians, 1/2 the radius squared times theta, which is all the way around the circle, which is 2 pi. Now what happens there is when you have a 1/2 that's being multiplied by a 2, those end up canceling. So the formula is just pi r squared for your area, which you already know. Okay, so let's do some examples and then you guys can do the you try. So in example 1, we're asked to find, or A, we're asked to find the area of the sector and the arc length, with the given central angle and radius. All right, so we'll go ahead and we'll find both. So the area formula is 1/2 radius squared times theta. Okay, so I'm going to go ahead and plug in my 1/2, my radius, and my theta. Now again, well, I'll show you that in a second. Okay, so 4 squared is 16. Half of 16 is going to be 8. 8 times 2 is 16, so that's 16 pi over 3. Okay, so if you would like, you could use pi r squared. I used 1/2 radius squared times 2 pi, but that's because I've got my theta and I've got my radius. So if you're given that information, it's best if you just use this formula here because it's just easier to plug values in. We use pi r squared when you are given pi as, 3.14, whatever, and the radius, which that's the formula you've seen before. Okay, so we've got one more thing to do here. We found the area. Now we're going to find the arc length, which is theta times r. So that's 2 pi over 3 times 4. So that should be 8 pi over 3. And if you are having trouble multiplying fractions, you need to get on that because that should be pretty natural by now. All right, so B, we're going to do the exact same thing, see what happens. All right, so plug in for the radius is 3. When you square it, it's 9. Theta has to be in radians, so you have to change the 45 degrees to pi over 4. Then you can multiply and you get 9 pi over 8. Ooh, I didn't mean to do that. All right. And now theta is pi over 4. The radius is 3. Multiply, you get 3 pi over 4. Try the next two. I think is there a U, or was it the U try? No, there is a U try. Try the U try, and then I'll show you the answer. Press pause. Okay, here's the answer. See if you've got any questions. Hopefully you did it right, and we are moving on. I'm going to get this video into one video today. It is going to happen. I think we have less material to cover anyway. Ooh, this is fun. A point on the terminal side of an angle x is given. Find the exact values of the trig functions of x. All right, so if we just graph this point, -1, -2. I've done that over here on the left. That's going to be in the third quadrant, right? So if I've got myself a right triangle, got myself a point here. The right triangle, we know the lengths of 2 sides, and we are missing the hypotenuse. Now, Pythagorean theorem, a squared plus b squared equals c squared. Now I'm squaring negative values, and negative times a negative is positive. This is 5, so that means c is root 5. Okay, now we're just going to throw all those values in, just like we did last class, and see what happens here. Okay, I put those all in for sine, cosine, tangent, and the reciprocals. You cannot forget the negative values. The only thing I have left to do is, and I took my sine and I wrote the reciprocal, flipped it. I need to rationalize the sine and cosine. So I'm going to have to multiply by root 5 over root 5, and I'll end up with negative 2 root 5 over 5. And then for cosine, I'll end up with negative root 5 over 5, rationalizing that in my head. All right, so try the U-try. The hardest thing is drawing the triangle. And if you're having trouble with drawing the triangle on your own, don't press pause because I'll show you the triangle first. Okay, so go ahead and you start by graphing the point negative 5, 12 and drawing the triangle. Do that, try to do it. Here's the answer. Now, when you draw the point, I think everybody can understand negative 5 is to the left, so that's negative, and then going up 12 to your point. You gotta put the negative 5 there. So Pythagorean theorem it, you get 13. You plug in all your values. I'll give you a second. Press pause so you can see if you can get the rest of it. Okay. And all your values go in like this. The last thing I want to tell you that a lot of people have trouble with is that once they draw this point, okay, I'm drawing in red right now, and everyone can remember to draw the hypotenuse. Sometimes they connect the triangle this way and then get confused. You need to remember when you are drawing your triangle, it is one of the 4 bow tie. You're connecting to the x-axis. Okay, so that's going to go down this way, and then it'll be pretty simple to get the rest of your triangle. All right, we're going to use even and odd functions, just like I was talking to you guys last class about. This is kind of where the even and odd functions come in a little handy. So we're asked to simplify these expressions. Well, if you look at A, we have do you see how our angles are all the same? 20 degrees, 20 degrees, 20 degrees. That means we can start working with them. Okay, if they're different, even if one's negative or we have a different angle value, we've got to get them all the same before we can do anything with them. They're all the same, so we can do something with them. Tangent, we know, is sine over cosine. So I'm just going to rewrite the tangent as the sine of 20 degrees over the cosine of 20 degrees. Well, now I have the sine of 20 degrees over the cosine of 20 degrees minus the same exact thing. Well, that just equals 0. Done. Okay. Now, for B, we have different angle values. So there are different ways of doing this. Okay. The first thing I notice is my 380 degrees. If I subtract 360 from that, I can rewrite my cosine as the cosine of 20 degrees. Okay, now I've got a 20 and I've got some negative 20s. Well, I'm going to change you could change them all to negative, you could change them all to positive, it doesn't affect me. But rather than changing the 2 negatives to a positive, I'm going to keep those negatives, and I'm just going to change the cosine to a negative because it's even. So I can rewrite this as the cosine of negative 20. So now let me rewrite the problem. So now I've got sine of negative 20 degrees, and you could have changed them all to positive. This is just a choice I made, over the cosine of negative 20 degrees minus, and this is tangent, so it's, again, sine over cosine. Hey, same thing, equals 0. Okay, now if we chose to make them all positive, when you pull the negative out, the negative's got to go in front of the sine. And for the cosine, the negative just goes away. For the tangent, it's got to go in front. So that would change it to a plus. All right, so I think, are we done? No, I don't think we're done. All right, so here's an example of the Pythagorean identity. Sine squared plus cosine squared equals 1. So notice the two terms we have here. We do have the same angle value, which is nice. We don't have to do any changing, adding, or subtracting or anything. However, we also have to use a reciprocal identity because this, we know, secant is the reciprocal of cosine. So I'm going to go ahead and rewrite that as cosine squared of the same angle. Well, now I've got sine squared of pi over 12 plus the cosine squared of pi over 12, so that equals 1. Done. And the very last problem is a you try. See if you can try it. See if you can use some of the identities we learned last class, and I'll show you the answers. Okay, again, this is what I chose to do. I noticed that the secant was the reciprocal of cosine, so the first thing I did was I rewrote it, okay, as cosine. And then I saw, all right, I've got different angles here. I've got, for the sine, I've got 17 pi over 8, and for cosine, I've got negative pi over 8. So I've got to make them all the same. So I decided to change them all to positive pi over 8. Okay, in doing so, when you change to cosine, you don't have to do anything with this, the negative just goes away. So that's where this came from, pi over 8. Okay, so now for the sine, I'm going to have to find a coterminal angle first. So I just subtracted, since 8, we're dealing in eighths for 2 pi. If I want to subtract 2 pi, that's 16 eighths. So 17 minus 16 will give me 1/8 left. So that's where this pi over 8 comes from. Now it's positive, and I can add them together. Sine squared pi over 8 plus cosine squared pi over 8 equals 1. Done. I think, yes, we're done. All right, peace out.